Medicine has spent considerable effort determining what to prescribe and how much to prescribe. It has spent comparatively little effort on when to prescribe, and accumulating evidence suggests that this omission has been costing patients measurable therapeutic benefit and, in some cases, causing measurable harm. Chronopharmacology is the field attempting to correct that oversight, and its implications for oncology, cardiology, and immunology are substantial enough to warrant serious clinical attention. The biological foundation for this field is the circadian clock, a molecular timekeeping system present in virtually every cell in the human body, governed by interlocking feedback loops of gene expression that cycle on approximately 24-hour rhythms. These clocks regulate the expression of drug-metabolizing enzymes, drug transporters, receptor densities, and the cellular repair mechanisms that determine whether a drug's action is therapeutic or toxic at any given moment. The time of day you take a medication is not pharmacologically neutral. It determines the biological environment that medication enters. The oncology data is the most dramatic illustration of this principle. Research on chronotherapy in colorectal cancer, delivering chemotherapy agents at specific circadian phases, has demonstrated that timing can improve efficacy by as much as 50% while simultaneously reducing toxicity. That is an extraordinary finding because it means that the difference between a treatment that works and one that doesn't may not require a new drug, a new dosing regimen, or a new delivery system. It may simply require better timing of what already exists. Cardiology provides a more accessible example. Clinical trials have shown that blood pressure medications taken at bedtime rather than in the morning produce significantly better cardiovascular outcomes, including reduced rates of heart attack and stroke. The proposed mechanism involves the nocturnal blood pressure dip, the normal overnight reduction in blood pressure that is impaired in patients with higher cardiovascular risk, which appears to be more effectively supported by bedtime dosing of certain antihypertensives. This is not a subtle statistical effect. It is a clinically meaningful difference in hard endpoints. The challenge in translating chronopharmacology into routine practice is twofold. First, circadian rhythms vary significantly between individuals. Morning chronotypes and evening chronotypes have genuinely different peak and trough windows for the same physiological processes, which means population-level timing recommendations may be suboptimal for individual patients. Second, the healthcare system is not currently organized to deliver personalized timing recommendations at the level of clinical detail this science demands. The infrastructure, continuous biomarker monitoring, AI-assisted timing optimization, patient education about chronotype does not yet exist in most clinical settings. The warning here is directed specifically at the gap between what the science shows and what patients are currently told. Most physicians prescribing cardiovascular or oncological medications are not timing those prescriptions based on chronobiological evidence, largely because the field has not yet achieved sufficient mainstream clinical awareness. That is a correctable failure. The evidence base for chronopharmacology is already strong enough in several areas to justify integrating timing into prescribing guidance, and the failure to do so represents a missed opportunity that is measurable in patient outcomes.